Hello, everyone. Welcome to this session. I'll be talking about how we use TuxSuite to build Yocto project and other things as well. Here's the agenda. I'll quickly cover what Linaro is, a bit about me, and what TuxSuite is, and how TuxSuite has helped the community over the last 1 year, and what's the motivation on adding support for Yocto project in TuxSuite, and some technical details on how we do the builds, what is TuxBake, what is the build definition, and some examples. Linaro has been around from 2010. It's been driving open source software development on ARM, providing tools, Linux kernel quality and security needed for solid foundation. We are working with member companies and the open source community to maintain ARM software ecosystem and enabling ARM architecture on new verticals. The Linaro developer services teams are helping build, deploy, and maintain your products on ARM. We also provide services that accelerate development, testing of open source operating systems and softwares. These are the key projects where Linaro is involved: the Linux kernel, toolchain, security, CI, CD, automotive, IoT, and cloud. These are just hyperlinks. You can click them and read more about that. Linaro has been an active member of Yocto project as well. Many of the Linaro employees contribute a lot. Linaro is also a simple member of Yocto project. About me, I'm currently working as senior engineer in Linaro as part of the Tux team, developing these cloud solutions. I have around 14 years of experience with embedded software stacks, as well as building CI/CD systems around them. In the past, I've worked a bit on U-boot, EDK2, ASP upstreaming, and a bit of Yocto as well. What is TuxSuite? TuxSuite is a collection of on-demand APIs and tools that execute in parallel at scale in the cloud for you. It is used to doing building Linux kernels. It is used to testing the Linux kernel on QEMU in the cloud. And recently, we've added support to build the Yocto project, OE, and other derivatives using TuxSuite. So TuxSuite can scale to more than 1,000 instances quickly within a few minutes, and it can then do your build requests as well as tests parallelly. Basically, if you have around 1,000 build requests, they're being done on 1,000 instances and expected to finish in minutes. We provide a TuxSuite CLI, which is a Python CLI application, which will talk to this API endpoints. If you wish, you can directly use the APIs itself and implement your own CLI. But with the CLI, it makes it easy for you guys to forget about what it is and just use it. The core backbone of TuxSuite are these open source tools that we've developed. These can be used locally by developers in their day-to-day building, and the same are used in the cloud to do the builds. And for Linux kernel, we provide something called as TuxMake. It's again a Python application which is which will then call Linux kernel make, but it uses containers to provide all the dependencies and standard build environment, which will help in reproducing the build locally in the cloud or in another developer's machine. Similar to TuxMake, we provide TuxRun, which again uses containers to run boot testing and LTP tests and a lot of the tests on QEMU. And we have implemented TuxBake, which is on the same design principles of TuxMake. We use containers to do Yocto project and OE derivative builds. All the three are Python applications. I'll quickly go through TuxSuite's use cases for the last 1.5 years. It's used extensively by LKFT. LKFT is Linux kernel function testing project from Linaro. They use TuxSuite to do their Linux kernel build, boot and run LTP tests on QEMU. using TuxSuite, and they have now started using TuxSuite to do their OE builds, which is used for building user space for the kernel testing. Just to give you some stats and perspective on the way it scales. On any day with their peak usage, they'll be doing build durations of around 2,000 hours. That maps roughly around 40 plus 8-core machines doing the builds for you for 24 hours continuously. But practically, whenever they have such a peak load coming in, all the builds are done within 3 to 4 hours itself. And they have a timeline of trying to get the RC testing done within stipulated time, and that's why they cannot wait for these builds to finish in a queue, and that's why this is where TuxSuite helps to scale and do the builds as fast as possible. On a single day, when they have like RC releases, they'll have more than 9,500 builds being done. To give you a perspective, more than 130,000 builds were done in April, compared to whole of last year. It was around 1.2 million kernel builds. The tool is used by Linux kernel maintainers locally to submit to build their kernels and test them. And that will allow them to do sanity check before pushing their patches for review. Another project is Clang-built Linux, which is around building Linux kernel with different Clang toolchains and tracking the Clang toolchains performance against Linux kernel. They use TuxSuite completely for all their builds. Their peak usage is around 1,000 hours, which maps to around 2,000 builds. For the last month, they've done around 54,000 kernel builds. There are more details about this projects in the presentation deep dive into Clang with Linux. Please have a look if Clang toolchain is of your interest. One more interesting project was the Monero project. They were using FEP models to run their Linux boot and Linux test and Android test. FEP themselves are very slow emulators that are used to emulate the ARM IPs. And their complete testing took more than 24 hours to complete for a single pipeline. We integrated it to run along with TuxRun and in TuxSuite in the cloud. And we parallelized those test cases. The overall, now all these test cases finish within 4 hours compared to 24 hours plus. How TuxSuite can be used? It's a CLI application which can easily be integrated to any modern CI systems and code review tools. We've tried it with Gerrit. LKFT guys use it with GitLab CI. Clang-built Linux guys use it with GitHub Actions. We use it internally with Jenkins as well. It can be integrated with Travis CI as well. Along with these use cases, it can be used by the developers locally to cover a wider build boot test locally before pushing those patches for review as such. Based on all these use cases and success stories, we thought it's a good opportunity to add Yocto Project and OE support in TuxSuite, and it will surely help the developers speed up their testing as well as building as well as testing not just developers, even CI systems as such. TuxSuite supports building Yocto project with the two backends. One is TuxBake that we have, and we saw that there's quite a good number of developers using CAS as well. So we support building CAS. Building with CAS as well in the cloud. And this is optimized. We use shared estate caching support as well as download DIR are shared. So once you do the builds, the artifacts are published into a non-guessable URL. And this is how the artifacts look in the web page. We'll go through that after the next few slides. And TuxSuite, I'll go in some details with TuxBake here. I'll not go in detail with CAS, but I'll show you the example of the two the builds with CAS as well. So TuxSuite uses TuxBake in the cloud to do the build. TuxBake can be used locally as well to do the build, as well as reproduce any builds that are done by TuxSuite. TuxBake is an open source Python 3 application to build Yocto project as well as OE derivatives. We publish these containers with all the dependencies for Yocto projects. And these containers cover almost all the officially supported distros, Ubuntu, Debian, CentOS, Fedora, and OpenSUSE. So TuxBake will run this container and do the build inside the container and provide you all the artifacts, and you don't have to bother about installing all the dependencies for your project as such. In terms of the container environment, TuxBake can use Docker or Podman to run these containers. We've come up with our own build definition template to describe all the layers that you wish to download, as well as specify BB layers, local conf, etc. So it'll be like one place where you have most of the description of your build put up, and that can be used, shared with anybody, and they can rebuild their rebuild the image across different users, and kind of reduce the complexity on how the layers are maintained as such. It supports fetching the layers using Git, as well as Android repo tools as well. And we have fields to describe your local conf, BB layer conf, environment variables, state mirrors, distro, machine targets as well. So the build definition itself is a JSON file with these entries. It'll take sources, and sources itself can take one of these three. It could either be Git trees, list of Git trees with the URL branch, as well as commit ID of that particular layers that has to be used for the build. And you can specify the end layers which are supposed to be used. Or you can choose to, if your sources are maintained using the Android repo tool, you can specify repo as the sources and specify the branch, manifest file name, and manifest repo URL. And the back TuxBake will fetch the code for you and use it. And third option is you can specify CAS as sources and specify the layers URL branch as and the CAS YAML file, which has to be used by CAS to do the build. env setup is path to the script relative to the source directory, which will set up your Bitbake environment. You can specify distro machine targets in this build definition file. The container is basically any one of these that are mentioned here. And you can describe your local conf, BB layer conf, as well as environment variables. The idea with these containers are you'll have the flexibility to validate your distro builds across different containers, across different host OSs, to know if there's any breakage or anything on a different build machine. Okay, this is, we'll just go through these examples as such. To install the TuxSuite CLI itself, you can use pip3 install TuxSuite, and the CLI will be installed, but you will not be able to use the CLI because you need a token as well to do these builds in the cloud. And there is a process to request for these tokens at the end of slides. And as well as the documentation on how to set up the token. So once you have TuxSuite installed, so this is the format of a build definition. Here we are doing a build of the Poky Kirkstone branch and a specific commit ID as well. And we're using the Git trees as the source to describe the layer that has to be fetched, and we do the build. So we have the container field, the script that has to be sourced, env setup, distro, machine targets, that has to be passed to BitBake to do the build. So let me just go ahead and submit this build. So this is the Yocto file, and I'm going to submit the build now. So TuxBake submit Yocto.json. So it's now submitted this build definition to the cloud, and now for each build we get this unique ID, which is what is non-guessable for anyone to check. But you can as well access, and you can share these URLs with other users with whom you want to share the artifacts. Currently, it is in provisioning state. It will take a couple of minutes for an instance to boot up and start building your code base. So it will then move to running stage, and then finally it will be finished, and whether it's pass or fail, we can check that. For now, let me just go back to the slide. So this is how the output would look. So it is provisioning a machine. Once a machine is booted up and it's starting to build your code base, it will move to a running stage. And after running stage, once the build is done, it will show whether the build passed or failed, and it'll have the build URL. So yeah, let me just go to the web page. This is a build which I had done before the actual presentation. So once the build is done, you have these directories created. So basically the artifacts here is the complete output of your deploy directory that is published, which you can access and download your images and any other files as part of the deploy directory which you wish to see. Along with these deploy directory, we provide the bitbake-e output for the user to check if they're interested in the environment where the build was done. Build log and build debug log are the same, except build debug log includes the timestamp as well. So this, hopefully it's visible. So it has the complete build logs along with the timestamp. And if you look at the end, you can see the build actually completed within around 90 seconds. And it actually had a 100% hit rate from our estate setup as such. So this is the logs as such. And the build definition is the file that we pass to TuxSuite itself with the commit ID and stuff. So you can download this build definition file and pass it to TuxBake and reproduce the build locally. For now, we don't have the feature of providing the estate with TuxBake, but that's something we will be working on. So if you look at the build now, it's moved to running state. So it took around a couple of minutes for setting up the instance, and then now it's downloaded the code and it's doing the build. With another couple of minutes, it will finish. While this happens, I'll just go ahead with the next example. So this is another example of a build definition where you have your environment variable set, where we are passing the environment variables. And in the sources section, we are describing, since Oniro project maintains its layers using the Android manifest. So we have specified this example covers how you specify the Android manifest repository. You specify the URL, you specify the manifest, as well as the branch which you want to build. Let me just go ahead and submit that as well, cat Oniro. So this is the build definition file. So let me just go ahead and submit it. Yeah, so now it's started an Oniro build. Let this also continue to run, and your local machine will be free while this happens. And yeah, this is again the output, how the build look. Yeah, let's go ahead with the third example. Let the builds continue to happen. I'll just continue submitting other builds as well. So this is a CAS-based build definition. With CAS, it has its own YAML descriptor file where you specify all the targets. So you don't have to specify any other fields when you're doing a CAS build. You just specify sources as CAS, and you provide the repository URL of the layer, as well as the CAS YAML file that has to be passed to the CAS tool itself. You can optionally specify the commit as well here of the layer that has to be built. Let me just go ahead and submit the CAS. So this is the CAS specific YAML file, and I'll just go ahead and submit. Build. So now it is building code base with a CAS repository. Let this continue to happen. We'll get back once the builds are done. Yeah, this is how the output would look in general. Okay, the next thing is TuxSuite has a concept called plans. The idea with plans is you can group a set of builds as well as describe the set of tests that you want to run, and you can just submit this plan file and it will do the build for you. The same thing we've extended for Yocto as well. Instead of the build definition, that being JSON, we have this described in a YAML file. This will not run with TuxBake. This is specifically TuxSuite. TuxSuite CLI will parse this plan file and submit it to TuxSuite Cloud, and eventually they are run as an individual JSON file itself, build definition template itself. But they are grouped together in a plan format as such. So if we look at this Poky next.yaml file, right, we have the common parameters for the master next branch. We're trying to build Poky with all on Ubuntu 20.04 container, and we have description about this plan file, and later we describe the jobs. The jobs take a name, user readable name, and bakes is where you'll be defining all the different builds that you want to do. Here we are doing 11 builds with all these common parameters and setting the different machine types to cover all the QEMU types that can be built. So this is single plan file, and once you submit with TuxSuite plan and this file name, it will launch 11 instances, do these 11 builds, and get back the results for you. And if you hook this up with the master next tracking in your CI setup, it will do these builds for you and give you results in a much easier readable format. So cat Poky next. So yeah, this is the file. We have the parameters, container, Ubuntu 24 distro as Poky, env scripts, and all the different builds that have to be done as such. Let me just go ahead and submit this plan. So now it's going ahead and submitting the plan, but instead of one build, it is now doing 11 builds together. And you get one single URL, which is with the plan ID here. The plan ID, you can use this URL. This plan ID will allow you to retrieve the results of all these builds together as such. Okay, so while this is happening, let me check. Yeah, okay, I just went back to the initial build that I had submitted. The Yocto build that I had submitted completed on the CLI. It took around 6 minutes because this includes the time taken for setting up provisioning the instance as well. So within 6 minutes, the build actually finished, while the other builds are still happening. The Oniro build is happening, the CAS build is still happening, and we have these 11 builds that are submitted that continue to happen. Let me just go ahead with the plan URL. So this will give us a window to see all these builds that are clubbed together and submitted. So it has all the 11 builds provided, and the current state they are in provisioning. One of them is moved into running. Basically, instance was provisioned and it's already running. So you'll also get the final results as well. So let me just check another build. Yeah, this was another plan which I had done previously to cover the builds and show the results that, okay, they have passed. So you can click individual builds and you will get to another page which will give you description about the UID, that particular build that would happen. This was for QEMU Risk V4, and you have your artifacts. So if you click the directory link, you'll go back to the build artifact URL page for that itself. So this is how the plan output in general looks as such. So you can basically write these plans to cover all the different end builds that you want to do on your layer, and it will do it for you, and you can quickly integrate with your CI system. Maintaining CI will be much easier in this way. And yeah, one more important thing is just, yeah, am I audible?
Yeah, we can hear you.
Okay, sorry. Lost. Okay, yeah, this is about the plan. Okay, where was the browser? Yeah. So these artifacts are hosted for 7 days, and after that they are recycled and they removed from the storage as such. That was one important thing which I had to mention. So yeah, this is how the plan will work, and yeah, the builds for the plan are still running. You can see the CAS build also finished within 5 minutes because basically it's all estate is already populated as such. The Oniro build is still happening. Hopefully it'll finish in another couple of minutes. While that is happening, I've provided these links. So this is how you can use TuxSuite with Yocto as such. For the layers, you can, in the CI system, you can hook the plans for pre-merge testing as well as tracking changes of your layers with the Yocto upstream as well. So I've provided these links for the projects. You can check and see how they are done. Nico has written pre-merge GitHub action, which will be testing Meta RPP as such. You can go ahead and check that, and this is hooked up with GitHub. So any updates or any PR that is created, the action is run and it will submit the TuxSuite build with the commit ID of that particular PR, and the build is done in the cloud, and you'll get the results, and you'll have the pass and fail results displayed there. Nico set up a Jenkins job as well, which is tracking the Poky master next builds as such. Whenever there's update, it'll trigger around 13 builds and give the results. Nico's done more work with the Meta Qualcomm layer as well. There are different multiple workflows that are published there, which describe about pre-merge testing and as well as branch-specific builds. So yeah, you guys can have a look and yeah, on how TuxSuite can be integrated with Yocto can be seen with these examples. Yeah, while these builds are happening, so once you've done a build, if you wish to reproduce it locally, you can use the TuxBake tool. This can be installed with pip3 install TuxBake. You specify the build definition file and a path where it has to fetch the sources and do the build, and it will go ahead and clone the Poky repository and then use the container to do the build. Let me just go ahead and submit that as well. Okay, here was it. So I have TuxBake already installed, and TuxBake can be installed and used without any tokens as such. TuxBake - build definition. So yeah, I'm asking to use the definition and download the code in the Yocto folder and do the build. So, sorry. So once you submit, it'll go ahead and do the build for you. Since I had the Yocto code base already downloaded, it directly went ahead with building the code for us. I'll just kill it. I don't want this to stop my machine. Okay, I'll try to be faster. In terms of TuxSuite Yocto roadmap, we want to hook it up with our Tux run and Tux test, so that you can define a plan where you build the images and as well as ask them to boot test in QEMU, and it'll do it for you. We still plan to add a flag no cache, which will allow us to skip the estate usage during the cloud builds. We plan to provide support to download these estate objects to reproduce them locally as well as debug if you have any issues. We have one more goal to use basically provide estate cache and download the IR from the cloud to TuxBake. Technically, it's possible. We still have to agree on how much can be kept open and cannot as such, based on the user's need, whether they want their estate cache to be public or not. For today, you can download the artifacts from the web page, but we need to extend our CLI so that it'll be easier for you to download the code base, the artifacts using the CLI itself. We plan to add statistics for the build around how much build time it took and all this data, which will help you create trends as well on how much it is taking from the time taken from compared to the previous builds and stuff. Thank you, everyone. So you can you can request for TuxSuite Token using the URL that I've provided in the presentation. We are looking for external beta users for TuxSuite with Yocto. This will help us improve. We are looking for feedback as well. This will help us improve Yocto support in TuxSuite, as well as see how other ways this tool can be used as such. These are the references you guys can go through. This is all the tools and the learn pages that we have around Tux tools, around the TuxSuite itself. You can read about other use cases, building kernel and running them in QEMU as well. The last link is around all the different examples that we have, which you can use as references while building your own build definition JSONs as such. Let me just see where the build is. Yeah, the Oniro build is done. Let me check. Yeah, even our plan specific builds are done. So you can see within the 30 minutes, we did like 11, 12, 13, 14 Yocto builds in the cloud, which I think is a good thing. Thank you, guys.